morning, good afternoon, and good evening, everyone. A warm welcome to day 6 of our 9 days webinar series, Disrupt or Be Eliminated. We deeply appreciate you for joining us today's webinar titled Precast, When and How to Make It Happen. We are really glad that we have audience from around the globe, and the response has been really very encouraging. Thank you so much. I am Gautam Das. I will be the moderator for the webinar today. Pinnacle is the leading global BIM service provider to the AEC industry in more than 40 countries. We cover the entire spectrum of BIM construction, starting from design to construction and facility management across all industry verticals. It is our passion and changed mission of all 1,500 Pinnacle team members across the global offices to stretch the technology and build an ecosystem of excellence to increase efficiency, reduce cost, and meet deadlines. We are grateful to our more than 1,200 clients spread across 14 countries for giving us the opportunities to work with them in past 23 years and allow us to work on the edges of technology. Today's session is going to be an hour long, wherein we will take you through our presentation for 45 minutes, and in the last 15 minutes we will address any questions you might have. So please keep submitting your questions throughout our presentation for consideration. Please keep typing your questions in the questions box window. We'd really like this webinar to be interactive. Right now, I have everyone on muted to avoid background noises that may distract you from listening to the webinar. So let's get started. It's my privilege to introduce our expert speakers today, Sudhir Singhamsati from ATMI Precast. Sudhir has over 15 years of experience in engineering and project management of a wide variety of all vertical structures, as well as the evolution, rehabilitations, and restoration of existing structures. In his current role at ATMI Precast, he and his team provide engineering support for the fabrication and erection of the ATMI Precast product line. Sudhir earned MS degree in Civil Engineering Structures in 2002 from the University of Illinois. He has been a licensed structural engineer in Illinois since 2006 and has served as an assistant adjunct professor of structural engineering in the University of Illinois. In 2013, he was awarded the Structural Engineering Association of Illinois Outstanding Young Engineer Award. Also, we have with us Jonathan Racknagel from Trimble. John has over 8 years of Precast experience. He graduated in structural engineering from university in 2012 and has professional engineering license in 4 states of the USA. He has spent 5 years working for a precast manufacturing company, 2 years in consulting, and now he is a precast application specialist in Tekla structure for 1 year. Let's have a quick pick on the points which we will be discussing today. When to adapt the precast technology in our construction project. We will discuss how precast will be beneficial in respect of social and environmental concern, how the whole system of precast works, and how BIM helps in smoothing the workflow. We will learn when is the right time for the BIM in different stages of construction, and a complete guideline we should follow and which we should avoid. Now, Mr. Sudhir, may I request you to take control of the proceeding, please?
Thank you, Gautam. Hello, everyone. Thanks for joining us for this webinar today. Sorry, I'm trying to control the slides here, just making sure it comes through. Okay, this first slide is kind courtesy of Dodge Analytics. Dodge Analytics is a North American analytics and software solution group that caters to the construction industry. And not long back, Dodge Analytics, in an effort to benchmark project delivery in the construction industry and to uncover the root of owner satisfaction when it comes to construction project, and more importantly, what differentiates an owner's experience in terms of a project being good, bad, or just an average. They interviewed owners across multitude of industries, and no surprises there. The two key aspects that any owner would like to optimize in the construction project inevitably ends up being schedule or budget. But what's surprising there is even on their best projects, 18% of them were completed ahead of schedule, but a staggering 26% were behind schedule, 21% under budget, again, 38% were way over budget. And once we start looking at their typical project, a staggering 35% were behind schedule and 42% were over budget. On-site construction in today's world is fraught with risk, and the risks of cost overruns and schedule delays we just looked at in the previous slide. But for an industry that pretty much relies heavily on skilled labor availability at the site, labor shortages also tend to rear its ugly head every now and then. Quality does tend to suffer when you're backed against the wall in terms of cost overrun and schedule delays. And depending on where the site is located, material availability might also be an issue. And that's where one can leverage the benefits that Precast brings to your project. Because Precast, pre-stress more often is in a controlled environment, produced in an organized manner, off-site construction. It leads to greater cost certainty and schedule certainty, and more often than not even compresses your schedule. And given that it's a manufactured product, it brings better quality to the entire project itself. And given the involvement of on-site labor is way less when in comparison to on-site or in-situ construction, labor issues is typically not something that you hear on a precast project. And given it's a manufactured product, a manufacturing industry typically has a well-established supply chain, that material availability is also not an issue. Those kind of advantages are backed up with data that is clearly shown in Dodge's prefab and modular construction report for the year 2020, where in their straw poll of all the stakeholders that are involved on a project, when they deem a project to be one of their best projects, 49% of those projects had some sort of prefabrication, precast, or modular construction involved in it. It's been in our experience that when you look at typical on-site construction schedule for, say, a 150,000 multi-story residential building, use of precast cuts down the time up to 30%, or in some cases up to 50%. And where do you find that schedule compression is right in the center, where once a general contractor starts site development and starts pouring foundations at the site, there is a simultaneous start of fabrication of structural and architectural element in a plant setting, so that once the foundations are done, you can shift the precast and start erecting. This has been strictly our experience, and I'm sure there are other listeners on this webinar who might have gained much more time savings in terms of getting the project to start off the grid. The structural benefits of precast and more often than not pre-stressed concrete is increased durability that comes in from the fact that there is a better quality control, better crack control. There is reduced deflections because of that very fact. And once you start using pre-stressed precast concrete, you can span greater distances and carry more load, which is a and or kind of a situation. And because of that very fact, there is a reduction in size and weight related to a similar conventional reinforced concrete cast-in-place member, which not only leads to savings on the precast and cast-in-place scope of work, it also has a benefit when it comes to design of the foundation elements. There was a paper in PCI journal, PCI stands for Precast Concrete Institute, which found out that in comparison to conventional cast-in-place concrete, the consumption of steel and concrete on a precast pre-stress project is close to anywhere between 45 to 60%. And when you talk about 45 to 60% of less concrete, it means that much less aggregate, that much less cement, sand, not to mention the formwork that is used to, say, shore and brace conventional cast-in-place concrete, and of course a reduction in water that would be used to cure the elements at the site. Those environmental benefits in turn lead to social benefits because you are using less energy to produce the cement or aggregate or sand, what have you. You're conserving forest and wildlife in terms of saving on the bracing and shoring. And there is automation in the construction process, whether it's in terms of manufacturing or erection, which leads to lesser human effort and lesser pollution. Some of you might say, well, precast has been around for a while. What's new? Well, what's new is the use of advent of technology, tools like BIM, which were not there, say, to the extent that we have seen today. So in the past 10 to 15 years, public and private entities are pushing the envelope of delivering precast projects. This is an example of a hospital in China, in Wuhan, that was at the start of this year, which was built in 14 days. Most of this construction tends to be modular, but there was a decent amount of precast scope involved too. The second one is the Vismaya New City. It is a self-sustaining state-of-the-art city being built by the Hanwha Group in Iraq, which has a capacity of 100,000 households and has a huge precast scope and pre-stress scope involved. That's making the possibility of building such a new city in such a short time. Having looked at some of these benefits, where can you use precast systems and what type of system? The only restrictions, if at all anybody has, is based on the foundation system, which might not support some of the heavy loads that one sees with precast concrete structure, and two, the availability of a local precaster. Apart from those two restrictions, pretty much you can, if you can dream of anything in precast, you can build it. A typical parking structure or commercial structure use frame system, which is basically beams or columns. Large wall panel system, whether they are insulated wall panels or just solid wall panels you see on residential structures or warehouses or commercial structure. Mixed system, which has both frame system and large wall panel system, typically finds its use in the healthcare and high-rise or mid to low-rise buildings. And on the civil utility sides, culverts and tunnels and bridges are something that's pretty common in terms of the use of precast is concerned. The next few slides we just see and walk through what and how precast comes to fruition. Precast system, as we talked, is basically production of different types of structural and architectural elements in an organized manner in a factory setting with high quality oversight and standards while being located remotely off a construction site. Some examples of elements that are fabricated are precast concrete columns. Like on the first picture you see on the left, it has concrete corbels The one without corbels are on the right side over here. And they could be used pretty much as pre-stress or conventionally reinforced, depending on the precaster's preference. Similarly, concrete beams, they could be pre-stressed or non-pre-stressed. They come in various shapes. IT stands for inverted T-beam, L-beam, R-beam is rectangular, T-beam, V-beam, which could be used as a girder. Precast concrete walls could be load-bearing, non-load-bearing, could be insulated, could be just solid, could be used as shear walls, could be used as retaining walls, could be just a facade of an exterior building. And in some cases, precasters go to the extent where they coordinate it with the window manufacturers and have the windows pre-installed in the concrete walls, even before being shipped to the site, and then ship it to the site and erect it in place in its final condition. Some specialty precast elements are bleachers, which typically find their use in stadiums and auditoriums and multiplexes, and raker beams, which support those bleachers, are also something that's pretty common in certain parts of the world. Coming on to the architectural finishes, once again, if you work pretty closely with your local precaster, they can pretty much make any finish a possibility, whether it's thin brick inlays or complex mold work or a foam liner. I think there are a lot of options out there, and same goes for tinting and coloring precast elements too. So what involves in the production process of a pre-stress or a precast element is, first you have to prepare your forms. You place your connection hardware, you stress the pre-stressing strand, which in my neck of the woods is anywhere between 1/2 inch or 6/10 of an inch of a strand. Place the mile rebar cage that's tied to the pre-stressing strand as support in some cases, or just use plastic supports. Batch the concrete, place the concrete, let it cure. Then the next day, remove the forms and strip the elements off the bed. Store it in the fabrication yard where you touch it up, and then ship it to the site and start erecting. A couple of pictures just to show what those processes are. So this particular picture coming from Precast Concrete Institute's website is just where you're jacking pre-stressing strands to fabricate prior to pouring of concrete. This is on the picture on the left is where the rebar cage is being assembled. On the right is where the concrete pouring. It's an architectural finished product in our plant at ATMI, where the concrete column cage, it's a white concrete, white cement mix that's being used on a concrete cage. And then you place the concrete, whether using tuckers or overhead crane, and then strip the precast element, again, whether you use an overhead crane or a moving crane, and then move it to storage, whether it's stacked or placed right next to each other, and put it back on trailers and ship to the site. And more often than not, you see on a precast building, you would see core braces or die bracing in order for the temporary erection, temporary stability of the structure before the final connections are made, or the diaphragm, which could be off precast or other material, is placed and tied back. So that's pretty much what's involved in a precast structure. But just like any other construction industry segment, it's has its own challenges. And one of the greatest challenges that we as precasters face is the lack of well-coordinated, timely availability of information. And that's where folks like John come in, and Trimble and Tekla come in. That would be my cue to pass it on to John, who will take it from here. Thank you.
Okay, thank you, Sudhir. Give us one moment while we switch over the controls here. Okay, now I have it. So this is definitely where Technical Structures comes into play to dramatically improve the business of precasters by providing the most complete and constructible information management solution. So next we're going to dive into how BIM helps improving the entire precast workflow. So starting out with BIM, you have one central model that's going to feed all of your downstream processes. So you're going to start with this model and take it all the way from the very beginning with estimating, pushing it through the design, coordination with other trades, and then you're going to push that into fabrication, where you're going to integrate with other production equipment, ERP systems, data management, and then all the way through full circle through the erection phase. The main takeaway here is that that model is your center point of truth. It's kind of your center kind of hub of your wheel that's feeding all of this data. So here, kind of like what we said a few slides back, is that here at Trimble, we basically support every life cycle, every phase of the project life cycle here. So starting at the very beginning, where we're, utilizing and optimizing, we're planning with SketchUp, we're, estimating through with Technical Structures, we're doing our design and engineering with Technical Structures and Technical Structural Designer. We're bidding projects with the WinS, Prolog, VCO, all the way through operating and management with Viewpoint. These are all under the Trimble family of software. So next, we're going to basically touch on the differences between a conceptual model and then a constructible model. So over here on the left, you can see we have a constructible model. We're basically modeling in everything that this panel is going to foresee in its future. All the plates, the bolts, welds, embeds, every rebar, any formwork if it's required, bolts, layout points. The nice thing about things such as layout points is we can push and pull data from Technical Structures using our Trimble stationing equipment, basically pushing data, pushing and pulling data, taking those site points out in the field, or taking point cloud data and pushing it in. This is what Trimble and Technical Structure strives for and does on every project, is we produce a constructible model versus just a conceptual kind of nice, pretty 3D picture. That leads us into BIM supporting coordination. So Trimble has a software solution called Trimble Connect, where you can basically take the model with you on the go. You can view it from the web browser or the desktop application, as well as on any smartphone, tablet, you name it. You can take it with you on the go. You can coordinate with other trades that do not have to be Trimble customers. You can invite your general contractors, EORs, AORs. You can basically invite all those trades to coordinate within one central model. Everyone can upload their IFC models in. You can do class checking. You can even link this with the Microsoft HoloLens to get that AR AR ecosystem. And then the next slide here will showcase a picture of the user interface. You can see we have that nice data-rich 3D model. Down on the bottom, you can save away all of your different views that you want to kind of cycle through. Here on the right-hand side, you can see all the models that are inserted. You can easily turn them on or off. You can run class checking, mark up things, take clip planes, assign to-dos to different people and say, hey, this needs to be checked. Can you do it by this date? You can have that running dialogue here. You also store documents within Trimble Connect as well. This is all within the cloud, and everything is backed up via the cloud. So now that we've kind of touched on some of that, data-rich kind of modeling, next we're going to go into pushing that data downstream into production automation. This is where the precasters really, gain the most bang for their buck. Technical Structures is linked with a number of downstream equipment and manufacturing items here. So over here on the left, you can see as far as rebar, we can export out our rebar to a number of different systems, whether that be ASA or Soulé, rebar vendors such as Schnell, linking with different ERP systems to push that data downstream, so that way you're not having somebody manually type in things or fat finger things. All that data that's housed within the model just gets seamlessly exported out through with no human interaction. Over on the right-hand side, you have linking with CAD/CAM systems, Unitechnic, robotics, and ERP systems also, such as Elematic, where you can actually push that data directly to your production equipment to be fabricated at your plant. All this being housed, obviously, with Preconstruction being that center of the hub. So next, we're going to kind of go into the benefits of modeling in BIM. We kind of have a stair-stepped approach with kind of 5 key takeaways here. There's obviously a ton more. These are just kind of 5 points to highlight here. The first being strong collaboration. The next one being optimizing your detailing time. Third, optimizing the construction costs. 4, kind of reducing those on-site repairs. And then ultimately the 5th one here, reducing the material waste. So let's start with strong collaboration. To kind of drive the idea home from what we've been talking about the last couple slides, Trimble also offers a service called model sharing, where you can basically house the model within the cloud, and then all of your employees, whether they're working remotely at the office or whether they're worldwide, can all be working from the same central model with Tekla model sharing. And basically how that works is the model is housed on the cloud, and all the individual employees download a local copy to their drive, so they can actually work offline on the model. And then whenever they want to either read in changes or write out changes, they just have to be on the internet for that process, and they basically just read and write out these small little packets. And what that allows is it allows for a seamless and very fast collaboration amongst all of your project stakeholders. And it also allows for that real-time data communication. It's all seamless, and most importantly, you're having up-to-date project information, so that way everyone is always working on the latest and greatest model. You can also pick and choose which packets you're going to read in, and kind of keep track of who uploaded what at what time, and it will show you a nice representation of everything that's changed. Next, we're going to go into the optimizing the detailing time. So this was a project that Pinnacle worked on with Clark Pacific. This is the Stanford project. Here's kind of a largely zoomed out kind of screenshot on the right-hand side of the 4 buildings. Some of the project facts here: we have about 1.8 million square foot of residences and about 14,000 plus precast panels. So as you can see here, with the estimated manually drawing these, each individual piece ticket and all the drawings associated would take about 261,000 hours if this project was done in a 2D CAD system. But using a product such as Tekla Structures, oops, hold on, looks like Sudhir somehow got control. Sorry about that. If you could just pass the controls back to me, that'd be great. There we go. I think I have them now. Not let me advance the slide here. Sorry everyone, a little technical difficulties. Are you able to pass the controls back to me, Gautam?
Just a second, John.
Okay.
All right, try it now. Click on the screen once and then it should.
There we go. I think I have it now. Okay, sorry about that, everyone. So as I was saying here, kind of modeling this in a 2D project, modeling this in a 2D software take about 261,000 hours. But using a software such as Preconstruction, they were able to model this in 145,000 hours. So, saving 116,000 hours, which is about 44% or something. Using Preconstruction, using the automated piece tickets, using some of the advanced custom components and automated rebar detailing tools, they're able to significantly cut down their project time here. Next, we're going to go to optimizing the construction cost here. So we won't go through every one of these cells just here for the sake of time, but this is per PCI journal here, and basically what this is saying is year one, you're going to have a slightly higher upfront cost. You've got to potentially upgrade your PCs, you got to buy the software, you got to get everyone trained up and everything. But really by the end of that first year, moving on to years 2, 3, and 4, you see a large benefit, $1.1 million. You're cutting down on errors and whatnot. Your individual drafters and detailers are being able to be that much more efficient. They're able to get more work done. They're able to export out more tickets and whatnot using a 3D BIM software such as Preconstruction. Next, kind of piggybacking on that one, is fewer costly on-site repairs. So in Preconstruction, you're able to run different predictions and iterations of the model that can adapt to changing circumstances. Some of our customers have estimated upwards of 40% reduction in these errors. And then you're also able to utilize, like I was saying in the previous slide, those intelligent parametric custom components to help cut back on any of those repairs. And basically what that looks like is within Preconstruction, you can develop these custom components that are basically intelligent. So kind of a good example, that would be a foundation embed to a panel base. You can basically have those two embeds linked to one another. So if one, changes or moves locations, the other one follows it. Same with like panel to panel. You can kind of incorporate all of that within Preconstruction to make sure that all of your embeds are accounted for and nothing is left behind. Another great example that happens often in Precast is with reveals returning. And when you're modeling everything in that nice 3D environment and you're using some of these tools that Tekla offers, you're able to grasp them better, and you're able to make sure that those errors do not happen that would ultimately lead to costly repairs in the field. And finally, we have the reducing material waste. So this is from the U.S. Department of Labor here. You can see some of these facts. I'll just rattle them off. 10% of material is wasted, 30% of construction is rework, 40% of job site work is unproductive, 40% of projects are over budget, and 90% of projects are late. And kind of the main mantra of Trimble and Preconstruction, we feel that this is largely due to ineffective communication, planning, and collaboration, all of which the Trimble and Preconstruction product family helps with. So some of the most typical precast BIM services, constructability review and coordination, obviously modeling the precast concrete 3D model, generating all of the required bill of materials directly from your Preconstruction model, generating all of your shop ticket drawings with our automated AI. That would include all of your wall panel drawings, beam, column, slabs, all of your embed and assembly drawings, and the like. 4D construction phasing, estimation, approval drawings, all of your production exports that we talked about earlier, all of your rebar, BVBS, BBS, automation, robotics, and the like. Next is a slide about some of the applicable codes. Obviously there is more than this, but this is kind of enough to just kind of highlight here. So you have the ACI 315 for design of reinforcing steel and details, ACI 318, which is the structural concrete code, ACI SP 66, which is the detailing manual. Then you have IS 13920, IS 456, and then the PCI design handbook. So next, we're going to start talking about some of the drawings that would be exported out of Preconstruction. Now, the big takeaway here is when modeling in a BIM software such as Preconstruction, your model is kind of your center point of truth, and then all of your drawings are just taking snapshots of that model. So if anything changes within the model, if you add embeds, add openings, and what have you, your drawings will automatically update. But this is a pretty typical kind of sequence of drawings for a precaster, starting out off with a cover sheet, general notes, legend, moving through all of your different plans, and then showing your sections, details, elevations, and whatnot. Here is a couple of examples of some projects modeled within Tekla Structures, and just to kind of show everyone the complexity that is being done. These are projects that are modeled all over the world. And then one more slide here showcasing some very complex Tekla Structures models. And moving on to some of the individual pieces here. So for the next couple slides, we're going to kind of pull apart each of the individual pieces and show you guys what some of the insides or what some of the the guts of these pieces look like. You can see how with modeling in a software such as Tekla Structures, we can readily see everything within the piece. We can check for clashes, we can coordinate with other trades and make sure that everything is ready to go when it's sent to production. So here's an example of a precast wall panel. Next, we have a moment beam on the top with a ribbed floor section down at the bottom. And then next, we're going to talk about numbering. So numbering is a process, prior to these BIM, prior to a software such as Tekla Structures, you would have to, manually compare all the pieces and assign different mark numbers so that way they can be produced. And that process can be quite cumbersome and take quite a bit of time, and as things change, as holes are added, if you need to place an invert or whatever, you could, but that whole process can just take a long amount of time. So whereas now with Tekla Structures, that numbering, that whole numbering kind of process is completely automated, and within just a few seconds, you can run numbering for your entire model. Basically, what that will do is go through and assign a unique mark number to each individual piece. It will also number all of your reinforcing steel, all of your embeds, inserts, lifters, things like that will all get a unique mark number, and you can control kind of how picky you want the software to be. If you want it to include certain things but exclude others, and what the tolerance of the software should be. This example here is kind of showing you that the numbering is working bottom to left to right. You can obviously change that all around within Tekla Structures to fit your standard practices. Next, here's kind of an example of that 3D model of these precast elements here, and kind of some of their typical numbering here. So W for wall panel, C for column, B for beam, and S for slab. The nice thing about Tekla Structures is all of this can be customized, and whatever you would like to set up, you can certainly do, so that way the pieces are marked according to your standards. Next is an example of a GA drawing, which stands for General Arrangement Drawing. These are the drawings that you would typically send out for approval, and these are going to show all of your section cuts, elevations, mark numbers, and everything like that. This is just kind of a side-by-side example of the real-life picture of it being installed on the left, and then the drawings from Tekla Structures on the right. Next, we're going to move into some of the shop tickets. These are the tickets that you would send to the production floor so that they can actually be produced. These are obviously necessary for the production of each individual unit. They completely define all the finishing requirements, the chamfers, all the fine details, the sills, the drip edges, things like that. And then they also include all of the details of all the material that are being cast inside of the piece as well. So all of your embeds, lifters, rebar, things like that. So we'll cycle through a couple of these tickets. The first one being the wall panel drawing here. You can see that we have these segmented out into top and form view, our section views on the side, and then our kind of the piece laid down in section views A and B down in the bottom left. But here's where these drawings are where we basically call everything out, we label everything, we throw all of the proper marks and everything all on the sheet, so that way it can be fabricated appropriately. Next is an example of a column piece drawing here, so kind of more of the same. You can see on the top right is the final product, and then the bottom right is the picture of it within Tekla Structures, and then obviously on the left is all of the views and whatnot from the drawings from Tekla Structures. As I said earlier, the very important takeaway is that you have this model that is the center point of truth, and then basically your drawings are just taking snapshots of that model. So as things change and update, your tickets and everything will update all on the fly. Here's a example of a pretty complex beam drawing here. You can see if you were to draw this in a program such as AutoCAD, this would take a tremendous amount of time to completely fill out all of those rebar bending schedules and keep track of all the different bar marks and properly label everything. But with Tekla Structures and its AI that we have, this drawing can be 80 to 90% automated with the out-of-the-box settings, and you don't have to worry about counting things, labeling things, keeping track of mark numbers. Tekla Structures handles all of that for you. So we're going to kind of wrap up here with some safe work with Precast, kind of the do's and don'ts. Some of these are more obvious than others. So the first one here is stacking and storing. So obviously with these pieces being produced at a facility, they need to be stored somewhere before they're ready to be shipped. So basically, very important to store these with the dunnage blocks going all the way up. You definitely don't want your dunnage blocks to look like in the right picture, red X there, kind of staggered around. You could definitely see some cracking in some of those lower pieces. The next, when it comes to lifting inserts and dog bones and whatnot, you definitely want to make sure that you're following your manufacturer's guidelines here to make sure that you're abiding by the proper edge distance. So as you can see on the left-hand side with the green check, we've placed that with the hardware manufacturer's edge distances in mind, making sure that we don't have a side pull-out or cracking or anything in that corner. So as you can see with the red X, we've definitely placed that too close, not abiding by the hardware guidelines there. The next one is pretty obvious with not working underneath any project, but you'd actually be surprised with how often that this actually does happen. With how busy we are, the fact that we're always on our phones and whatnot, it's very important when you're on a site to really make sure that you always have the crane in mind, and where the crane is at all times, and making sure that we're not walking under any of the precast elements. The next one here is not more or less a do or don't, it's just kind of more of an explanation here, but typically on the bottom of these wall panels we have, most typical is a 1-inch gap with some shims at the bottom, but that gap can go all the way to 40 millimeters, which is about 1.5 inches. Basically what that's there for is to take out any uneven surface within the foundation, so you get a nice flat plumb panel, and then that bottom of the base is grouted solid. Obviously, again, with these pieces being produced at a facility, they have to be shipped on site. So in doing so, they can either be shipped on A-frames, as you see with the pictures, or they can be shipped on face, basically flat. But it is very important to make sure that they're well restrained, so that way we don't see any crackings or any pieces or anything like that want to obviously fall or fly off during transportation. And then ultimately, with these pieces being shipped on site, they need to be installed with a crane. So very important, we check for the center of gravity of each of these pieces to make sure that once the piece is flying with the crane, that it's not wanting to spin or kind of rotate one way or the other. Next, so some of the limitations, we've talked about all the pretty roses with Precast, but there are, of course, some kind of downsides to it. It could be costlier for some smaller project. You could require some skilled workers for both, in the plant, in the field, or in the office. Transportation is obviously, a large cost, and it can cost more for the larger members also, because you may need special permits, you may need follow cars, and also most of these precasters are kind of limited in their radius. Typically they're only going 1, 2, 3 hours kind of distance away, and then apart from that, the cost for shipping is typically too high. And then also there is an extra level of carrying that is required during the transportation and erection phases. Some of these panels and whatnot, some of the highest stresses that the panel will see is actually during those first phases of stripping, erection, and trucking. So making sure that the panel can safely make it there without having any cracks or spalls or anything like that, there definitely is an added level of care that is required. But apart from that, I believe that wraps it up. So I will turn it over to Gotham for a Q&A session. Thank you.
Thank you, Sudhir and John, for a very informative and detailed presentation. Now we will go ahead and take some time for questions. Just a reminder to the audience, please be sure to type your questions into the questions box in your control panel.
Okay, thanks Sudhir and John. This is Bimal here. So John, you said that it is costlier for small projects. So what is the break-even point? What do you think? How do we decide whether we should go for precast or cast in situ? So what are the decision criteria you suggest that a company should take?
Well, obviously, I'm definitely a proponent for so I would just suggest reaching out to the precaster and getting a quote for it, so they could, model up the project in Pinnacle Structures and kick it all out to their estimation software and get you a price very quickly. But I've seen and been involved with projects all the way from small house jobs all the way through, very large commercial projects. So, I would definitely recommend just reaching out to that precaster and figuring out what is going to work best for the investor/owner.
Sudhir, what do you think? Thanks, John. I think that was interesting. So, Sudhir, what do you think? Will you supply your products to any project, or you look at any project when it is beyond certain size? How do you decide when to get into a project?
Going back to what John said, our first thing is to make sure we can put forth a precast solution to solve the client needs. But more often than not, I think the first thing that we do look at is transportation, is how far it is from our location, just irrespective of the size of the project. That tends to be one of the key elements which breaks or makes the project. And then two, it is for a smaller project, I think it all comes to how hungry we are for the work and that particular time frame and schedule. But for projects of much larger scope, it all comes to, in my opinion, mostly with the foundation design and the wants and needs of the client. Because sometimes there is, we at HMI are more a structural precast company, so we can't give everything, say, an owner or an architect needs in terms of finish. So we might be disadvantaged at that. But on a large project, we do make the accommodation, because we are architecturally certified by PCI, to take on that work. But the same thing, we would not do that on a small project. Does that make sense? Because just the business logistics side of things does not work for a small project versus a large project. And if it works for a small project, it typically depends on the availability and space or beds being able to take a small project and knock it off quickly. But in my limited experience, it's been typically foundation and transportation. Those are the two biggest game changers, whether to go with precast or not.
Excellent, Sudhir. In MEP, we have seen projects where the contractors carry almost for 800 miles. Also, we have seen some projects where they've carried the prefabricated parts, but I guess they are much lighter. So in your case, you said you raised this point of transportation cost. So where is the break-even again for the transportation cost? Because precast again, it has to be far. So how many miles can somebody, like for example, your factory, what is the radius in which you can go up to supply your precast?
So we have a sister plant in Indianapolis, which is again 2 or 3 hours away. So between us two plants, we try to cover a radius of 200 to 300 miles. But the time constraint of 2 to 3 hours is also a good point that John mentioned, because trucking becomes efficient when the trucker who gets to deliver that precast element is able to drop the trailer back at our facility because we own the trailers. Once you tend to extend that trip by more than a day, then you have to pay for allowance and overtime for a trucker. And the trucker also by law has to take multiple stops, which kind of adds cost to the entire process. Sometimes it almost triples or doubles the trucking cost, one. And to your point, whether you have seen where some precasters ship up to 800 miles. Yes, when it's a specialty cladding or only 1 or 2 precasters in the entire country, at least from in the North American continent, can only make that. Or like I know last year PCI advertised this 3D printing of a cladding panel that was done on a complicated facade of a tall building in New York. Yes, there was a long transportation cost. I guess it all comes to because we lose projects just based on transportation costs, but if the owner has a strong preference to go with a particular precaster, then declaring those costs way ahead of time, and once the owner accepts that cost, then it's a non-issue.
We now have a lot of questions coming in. So the next question is about the economics. How much it would take to set up a precast industry plant cost to be a precaster? What would be the space requirements and how many years can we reach a break-even? So what would you suggest a contractor to have his own precast, or the economies of scale demand that it's a specialized job like your company does, and it should be left to the specialists like you? What would you recommend to the industry?
Yeah, I would say talking to an existing precaster to set up a facility close to this big project or whatever it is would be the first starting point, to see if there is any other precaster who is interested in establishing a facility closer to the location of the project, because there are a lot of things that need to happen in order to make sure that a precast facility is a viable option versus a conventional cast in place type of an entity. For example, we are constrained by space because we are a landlocked facility over here. So, we had to lean on to some really interesting things that we have to do around in order to make the best use of space. But most precasters are blessed with the vast area of storage facility, so they can spread out much further. So I would say land is one big restriction in terms of setting up a precast facility, and two is the being close to the source of aggregates and sand and cement. That's one more crucial point, because you need to have your supply chain in order to get the materials to your site in order to work efficiently. Third is labor. Having a continuous stream of labor who are willing to work in the precast industry. So I would say the availability of land and labor and close to a quarry of some sorts or a cement manufacturing facility would be, your 3 key things that you need to look for if you are in the business of setting up a precast plant. And talking to an existing precaster who does not have a foothold in that area would be the starting point, in my opinion.
Made such a compelling presentation for the use of precast. I mean, it saves time 30%, it saves cost, it is structurally good, it eliminates errors, low wastages. So what is then holding us, and is precast prevalent all over the states, in every state, in every area, county we have precast? So what is holding us, and how do you see the trend in the next couple of years, precast spreading all over the US or all over the world, I would say, because we have audience from all over the world. I've seen a lot of people from Saudi Arabia, from Middle East, from Singapore. So we have people from different countries today. So what do you think? And John, a question to you, like how does Trimble see adoption of precast across the world? Does it depend on, what does it depend on? Why the adoption? Is it uniform across the world, or is it more in certain areas?
Yeah, sure. So I would say from Trimble's point of view, what we're seeing and kind of what I've personally seen is I've seen a huge influx in the precast use over the last, I don't know, maybe 5 or 10 years. We have a headquarters in Finland, and over in the Finland area, most projects are precast. I think it's somewhere like 80 to 90% of the projects over there are precast, and they're using technical structures with automation and whatnot. I think the world is starting to go more that route. They're just seeing too many benefits with precast. Like you've said, I think we're the whole entire world is just kind of coming around to it. One thing that I will also add is that the precast facilities are a little bit in the dinosaur age, and they're kind of just starting to come up with the robotics, automation, and things like that, at least here in the States, that is. So I think as soon as a lot of these precast manufacturers kind of kick it up a notch and kind of try to model more or less the auto industry, I think you're going to see precast explode even further. So that's just kind of, I guess, what I've seen in the past couple of years.
And from my perspective, just the lack of exposure and knowledge for, say, even students and architects and engineers who are studying in current, and their exposure to precast, and then once they come out and they tend to practice the same conventional materials, whether it's wood, masonry, concrete, or steel. Just the fact that not much is spoken about when somebody is getting their degrees. 1, 2, because of that, an architect or an engineer would not propose a solution to an owner to solve their problems, which is hinged on precast. And that awareness and education has to come from the grassroots level, at which I think PCI is doing a good job at that. And that is one of the hindrances that we see. I mean, I was a practicing structural engineer, and doing that for 13, 14 years, I think can count only 2 or 3 buildings that were strictly a precast solution, because it was already preset by the architect to go in a certain shape and form. But it's changing pretty fast, and the schedule and cost benefits outweigh pretty much anything and everything that's out there. And something like insulated wall panels that we do pretty heavily, that add to the benefit of being energy efficient, also reduces the amount of other scope of work and trades involved, whether it's like drywalling and insulation on the inside. So I would say it's just market education and owner education that takes quite a bit of time. But at the same time, with the advent of technology, BIM, and increased speed at which things are being delivered from, say, a facility to the site, all of it points and augurs well to the increase of use of precast in the industry.
That was very informative. So there is another interesting question from Mr. Khaiz Ibn Subair. Mr. Subair, we would like to unmute you if possible so that you can ask the question. Can you unmute yourself and ask the question, please? Any anyway, let me ask that question to save time. So his question is that you have mentioned about the hospital in China, which was built with precast in 10 days. But we know that concrete needs some time to attain strength. So how precast is attaining this strength in very limited time? So what are the techniques to get strength quickly? How do you cure your concrete? Sudhir?
Yes, overnight we easily achieve, sorry, I cannot get the equivalent SI units, but we easily achieve 5,000 to 6,000 PSI in very remote warrants. But 5,000 PSI, anywhere between 4,000 PSI to 5,000 PSI is the norm, just due to the use of admixtures. And the one thing that we have seen helps immensely is to making precast in covered facilities. You just can't have precast beds, exposed to the weather. That affects anything, everything downstream. That controlled manner fabrication is a key aspect. So ATMI has everything under a roof. That was not to be the case 2 or 3 years back. And we have seen immense improvement in our quality control and the product that we deliver because of that change. So
you are saying,
go ahead.
So you're saying that in 24 hours, the precast is ready to be shipped after casting? Like, what is the earliest you have been able to ship?
We have been able to ship in 2 days.
In 2 days, okay.
Yeah, and that is all because we need to realize that the final design strength that's needed is for the final condition when the service loads are imposed. And for erection, some of the strengths that are achieved that we can live with that in terms of temporary erection loads because it's not seeing the full final service loads. We are able to sustain them because of our bracing techniques, of our guide bracing, and so on and so forth. So achieving those strengths has not been an issue due to the material advances and concrete technology. And we work very closely with our admixture supplier and chemical supplier when we are in a bind to fix an issue like that. So at least strength grain has not been an issue, but unless of course you are looking at pretty high strength grain, that's a completely different issue. But for nominal design 5,000, 6,000 PSI, it's not been an issue. And that design strength, by the time you want the 8,000 and 9,000 or even 10,000 PSI, in 14 days, which that project was, again, that project we mentioned was more modular construction with some precast scope involved. But nevertheless, strength of concrete has not been a limiting factor for us to deliver pretty quickly to the site.
Thanks, Sudhir. The next question is from, I know we have crossed the time, but they are very interesting questions and I would like to still place it before the panel. I hope you can answer that. And Gautam, you are also most welcome to participate in these questions. So this is saying that how can we implement the BIM and get maximum results in minimum time? So engineer Mohammed Usman from Saudi Arabia, he's asking this question. So to rephrase his question again, that how critical is BIM, because you are precasting and you can't afford to have any mistake because the whole sequencing will get haywire. So how important is BIM to this whole process, and how do you make sure that you have a good team, and is it a challenge to get good BIM service providers for this type of work?
Sure. So as far as how important it is, I think it's extremely important. It's one of those things where you're either going to get into it or you're going to kind of get left behind, right? Because there's more and more projects that are coming out, especially governmental projects that are requiring BIM. And as you saw by the couple advantages slides, that you're actually losing out on money and potentially projects by not making this investment. As far as finding work, as far as finding workers, basically anybody that has drafted in the past or has any kind of 3D mindset, I've found it best to find those kids right out of college, and you basically get them up and running very quickly. The time to implement a software such as Tekla Structures is very, very small. Within just a few weeks of training, they can at least know the basics of the software and kind of how to set things up. But I think it is extremely important. One of my recommendations for just getting started would also be to either reach out to your local Tekla Structures office to work with kind of working with them on a kind of project by project basis to try to help get set up. What you could also do is work with a consulting group to try to help get your standards set up and get your drawings and stuff up and running. Those would be kind of the two routes that I would recommend there.
Sudhir, how challenging do you find? I know we have been also supporting your company for some of the drafting and BIM coordination requirements. How do you see the availability of trained resources for this type of work?
Training does take some time. I won't lie. Anywhere between, depending on the skill set of folks who are coming in, it takes anywhere between 3 months to 6 months. So it all comes back to whether the precaster wants an on-site engineering team or prefers to have a lean mean construction machine where basically you have the in-house team taking 30-40% of the workload and the other 60% being taken by a consulting team member like you. And there are advantages to both of them. If you have an on-site machine, given that precast is it's a fast-paced environment, things change at the drop of a hat. Having an on-site engineering team helps, but when the workload is so high that you can't have it, so the company or the engineering team has to be flexible in having both an on-site as well as an extended arm of their engineering capabilities, because you need to have both in order to survive this industry and the pace at which it works. So in my opinion, training does take a little bit of time, but that's where having friends like Pinnacle right next to you will help in the grand scheme of things. And to go back to your first question, not having BIM capabilities in today's world is to your disadvantage. ATMI didn't jump on that bandwagon until like 5 or 6 years back, and we are slowly but steadily realizing the benefits of having BIM in our processes. And it just does not stop at engineering and drafting, it extends beyond engineering and drafting. It helps our purchasing, it helps our erection logistics planning, it helps our production planning, it helps in sales and estimation, it helps in accounting. So it's across the board. So it cannot be just seen as an engineering or drafting tool. It's much more than that. And the first step is to recognize that. And once you recognize that, John and Trimble offer so many resources and so many software programs that sky's the limit in terms of how far you want to push.
Okay, all right, Sudhir, John, once again, I'd like to thank all of you for such a wonderful presentation and interaction. I'd like to thank our audience who have very patient and keep asking questions and taking part, encouraging us for this webinar. I'm delighted to know that many of the audience have been participating every day. This is the 6th webinar. Thanks to their support, and promise to you that next 3 days we have remaining 3 webinars, and we'll be touching the entire spectrum of the AEC industry. And we look forward to your feedback. Please do give your feedback so that we can improve our presentation and improve the whole topic, which is close to our heart, which you want us to talk about. So thanks and have a great day. Stay safe and take care. Thank you.